I'm Kirk Harnack. On This Week in Radio Tech, I'm joined by Chris Tarr, Chris Tobin, and Tom Ray. We're talking about noise, RF noise, increasing RF noise that's making radio communications more difficult in some places. We're just about to add to that noise. Twerk is up next.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for This Week in Radio Tech is brought to you by Cachefly at CACHEFLY.com.
This Week in Radio Tech, episode 91, recorded July 13th, 2011. Devices in Aggregate. This Week in Radio Tech is brought to you by Omnia Audio and the new Omnia 11. Big market radio engineers are calling it effortlessly loud. Check it out at omniaaudio.com. It's time for This Week in Radio Tech. Hi there, I'm Kirk Harnack. I'm glad that you've joined us. This is the show where we talk about all kinds of things having to do with radio technology, including RF and transmitters and antennas, studio issues, audio consoles and audio processing, even microphones like this Heil microphone that I'm talking on right now. And this show wouldn't be anything if I was doing it all by myself. I got some co-hosts here that add a lot to it. In fact, I'm going to depend on them for this show to bring you all the information you're going to hear. First of all, let's go in a reverse chronological order. Let's head out to Mukwonago, Wisconsin, and talk to Chris Tarr. Hello, Chris.
Hello there, Kirk. And I'm the Director of Engineering for Intercom's radio stations in Milwaukee and Madison. And I'm also the engineer here. Let me stand up a little bit there. There you go, an engineer. And I also run the website broadcastengineering.info.
Very cool. I appreciate that. And also from another Chris from Manhattan. We call him the best-dressed engineer in radio. It's Chris Tobin. Hello, Chris.
Hello, Kirk. Hello, Chris. Yes, I'm the broadcast technologist for CBS Radio here in New York City. We have 6 stations, 3 AM, 3 FM, and we have a good time broadcasting throughout 8 million people. It's fun stuff. And my job is to find technologies we can use to make money and keep the stations afloat. So it's always a challenge every week.
Very cool. And also from New York, but he lives in the Hudson Valley and commutes in every day. It's Tom Ray from the Hudson
You
Valley.
had to remind me.
Sorry.
Hey, Kirk, I'm Vice President, Corporate Director of Engineering of Buckley Broadcasting and WOR in New York. And by introducing me, you've just taken the show down a notch.
Oh, no. Jeez. Hey, and for me, I work for the folks at Telos, Omnia and Axia, now known as the Telos Alliance. And somehow they saw fit to make me the supreme potentate in charge of sales worldwide. And I guess they got a bit of a background in engineering, so that works out pretty well. And I seem to know a lot of folks. I do have a little side job. I am part owner of 4 radio stations, 2 in Mississippi and 2 in American Samoa. So actually do some engineering, keep things on the air from time to time. I've got a couple of engineers who handle things when I'm not available. But so I actually try to keep my my hands in the soup, so to speak. Hey, this is episode number 91 of This Week in Radio Tech. And we're going to cover a few topical things, look at just a few things before we get into the meat and potatoes of what's going on. One thing I wanted to mention is this issue of background noise. And actually, maybe that was one of the hot topics that Chris and Tom wanted to discuss. Background noise, and what I mean is by that is RF noise. And noise, this is just general broadband noise produced by just a whole litany of different products, a lot of consumer products that are making it difficult or more difficult to pick up radio stations, especially weak signals. And let's kind of see if we can try to define, what has become of radio reception. And by the way, when we talk about, we as engineers are talking about this in terms of its impact on AM and FM devices, but it can also have an impact on lots of other receiving devices, such as the Wi-Fi receiver in your laptop or in your iPod or in your iPad. It can affect if you're trying to pick up say a WiMAX signal or an LTE signal, and if the general noise floor gets higher and higher, you may have a hard time picking these things up. So not only is it something that is affecting legacy broadcast transmissions or the reception of those transmissions. Transmissions haven't changed, just the noise picture has changed. But it can also work its way into affecting new digital services that we've been enjoying. So with that said, let's kind of round robin this. Chris, Tarr, I started with you. Let's come back to you. Tell us what this increase in background noise means to you, and see if you can define the problem a bit better for us.
Well, actually, it doesn't really affect me too much. We're in such, I think, we're in such a kind of a sparse area where the noise floor really isn't really getting affected by this. And what they're talking about a lot of times with the noise floor, with all these additional electronics and portable devices and all these things that are out there today that are essentially RF noise generators, that the overall kind of noise in the background has gotten louder and louder, and the interference has gotten greater and greater. Now again, in a city like New York, as Tom and Chris will tell you, I'm sure the noise temperature, as they like to call it, is much, much higher than it is in a place like Milwaukee or especially a lot of places in the Midwest where there's really not a lot going on. But you start adding those little portable transmitters and the XM and Sirius transmitters and all those different things for iPods, it all starts to add up pretty quickly.
And actually, Chris, I wanted to bring you in first in the conversation because you do live in a sparse, Wanago, really? Wisconsin? So much of an urban island effect there with a lot of people crammed into one space. I was thinking about some of the devices that are around me that can generate RF noise. And, RF noise can be generated just by digital circuitry, because there's all kinds of relatively high frequency square waves going on inside digital circuitry. So even, for example, I'm using a mic preamplifier here. Now, I'm not saying that this is generating noise, but this is a Shure X2U. It's mic in on one end and USB out on the other end. Well, the USB part is digital, and I know that there's sound card digital stuff inside this Shure X2U. Also, I'm sorry, Chris, go ahead.
Well, and it's not even things like that. You think about the fact that LCD monitors generate hash,
Sure.
Computers generate hash, the clocks in those. It also a lot of times answers the question. A lot of people wonder why, especially with portable digital radios and HD radios, why there's no AM on them. Well, because of the processors in them generate so much noise that AM would essentially be useless on these radios. But what they're talking about now is it's starting to creep up all over the bands, not just AM anymore. And especially in the problem you have with HD radio, the analog signal is pretty robust, but the digital signal is essentially AM, and it can get interfered with that way.
Other devices I've got here, an iPod. I'm not saying that this has a certain amount that it's allowed to put out in terms of its digital circuitry, a certain amount of electromagnetic radiation while it's doing its job. Of course, a cell phone like this one, it's a transmitter. It transmits on cell phone frequencies, but I just got to believe that the transmitter is not 100% clean. In other words, that there's a mask under which the transmission energy must fit under, but there's also noise being generated, again, by the digital circuits inside that very cell phone. There's also problems with noise energy coming from things like compact fluorescent light bulbs. Those things are just a wealth of noise generation. Another source is these switch mode power supplies. Even little wall wart power supplies that are switch mode, they can make all kinds of noise themselves. In fact, when I was doing more amateur radio work, I had a switch mode power supply in my home that produced some RF energy right on the frequency of a repeater in Nashville, Tennessee that I wanted to listen to. And the only way to listen to this repeater reliably in my home was to unplug the switch mode power supply. I think it was for the cable modem that I was using. So I needed to have that plugged in. Mr. Tarr, you live right there in the thick of it there in New York City. I'm guessing you live in a building that has quite a few other residents as well. Tell me about your experience with RF noise.
Oh, yeah. There's plenty of noise here in town. Matter of fact, just my computer alone generates enough noise that one of my two-way radios I have here, I'll show you a picture, happens to have a frequency in there for 486 megahertz, which is one of the fire department channels here in town. And when I fire up the computer, the squelch opens up, and suddenly the receiver no longer functions. So there's noise right here localized. And then I have a spectrum analyzer I brought home the other night, and I started put an antenna, small little whip, about 6 inches on it, and the background noise, when there's nothing connected, the noise floor of the receiver, the unit's like 120 minus 120 dBm. I pop an antenna on that, and it pops up to around 98, 102, minus 102 dBm of noise. It's interesting. It varies. But yeah, it's noisy in this building and here in town. It's wild. It's just the article that we're talking about in the radio world. Let's see, that's the guy who did these tests is Steve Johnston. So you were asking earlier, Kirk, about who was the author of that. He's the director of engineering and operations for Wisconsin Public Radio. So we give credit where credit's due. I know there are other people that have written articles of similar ilk, but at least this one is the Radio World June 15th edition, for those of you who are interested in looking it up. And he points out that the noise in the home has gone up, or is up, and in the office as well. And I know we've been receiving over the last year or so a lot of calls for our AM reception. A lot of listeners complaining that they don't get the signal or hear the station like they used to in many familiar places in their home, in their neighborhood. And it's interesting over the last, 2 or 3 years, the amount of smartphones and technologies that have come to the forefront. I'm wondering if that's brought the average noise floor up. I know using an FIM 21 AM field strength meter out on the streets of Manhattan, and Tom knows, you can dial it up and the needle just starts moving and it's just static. There's no intelligible audio, it's just static. So I can't imagine what it's like in people's homes. Oh yeah. And and it's not just electrical noise. There's thermal noise from the heat. There's all kinds of noise. I've been reading up about noise temperature, as Chris pointed out, and it's all over the place. It's amazing what can contribute to it. And then receivers that are really sensitive just become more deaf as a result. It's wild. And his article talks about FM too.
It does seem like for years, people interested in radio and radio reception, especially weak signal reception, like folks in ham radio do, or if you're an engineer for a broadcaster, you often want to see how far your signal goes, so you're driving out in weak signal areas. And certainly there was a time before these modern times when you'd run across interference from, say, fluorescent lights that are fairly localized, or from perhaps a power utility company would have a bad insulator somewhere, and the noise would be emanating from the high tension lines up and down the road for a long time. In fact, I remember when I lived in Mississippi just a few years ago, 10, 12 years ago, there was an FM repeater that I wanted to listen to on my ham radio, and for a several mile stretch of U.S. Highway 61, north and south over on the west side of Mississippi, I couldn't hear that repeater because of just all this noise that seemed to be coming from the power lines. I never discovered the source for sure, but it was localized to an area and then following along with the power lines. So those are two sources of noise that we've often contended with as studio builders, broadcasters, with fluorescent lights, or trying to listen to an AM radio station in a fluorescent lighted area, especially if you have a ballast going bad. That also can contribute to it. But in more modern times, here in just the last few years, we sure have seen a big increase in additional noise sources. And it'd be interesting to try to characterize just what these sources are, is how much of it is from compact fluorescent lighting and the little power supplies, the switch mode supplies. And I should point out, I've mentioned switch mode supplies a few times. A linear power supply uses a big heavy transformer and probably some diodes and some capacitors and then maybe a regulator to turn AC power into regulated DC power. But they're kind of heavy and a little bit expensive because of all the iron in them. Nowadays, you'd get a wall wart power supply. Like here's a great example right here. Here's a little power supply for a cell phone, and it's extremely lightweight, doesn't weigh anything. Well, there's almost no iron in that. There's certainly no big transformers in that. I better plug my cell phone back in. It's got a switch power supply in there, and also it's wide ranging. The input can be 110 volts or 240 volts. It doesn't care. It's going to put out the right voltage for charging my phone. Well, this thing, I assure you, is noisy. I wish I had a spectrum analyzer right here, and we could check it out. Maybe if I had AM radio, I could check it out for you. But these are additional sources of noise. And just all the electronics that we have. Somebody mentioned LCD TVs and LCD screens, that they can put out a lot of hash. One of the engineers on this podcast who makes his living from AM radio, which is certainly one of the first things to be affected by noise because of the way it demodulates, is Tom Ray. Tom, you got to be putting up with all kinds of problems there in New York City with WOR reception.
Well, we are, and actually Chris mentioned the FIMs before. One of the other characteristics of using an FIM in New York City is you can go to certain intersections, and because of the way the signals bounce off the building, you can take that FIM and you can turn a 360-degree circle and you can't see the meter move. You cannot null it. You can't do anything. But where I live up here in the Hudson Valley, it's in the null of the WR signal. WR nulls towards the northwest. And I'm about 55 miles out from the transmitter site, and we're putting maybe about 5,000 watts in that direction. So, it's a pretty weak signal. Even though it's a low frequency, it's a pretty weak signal up here. So my routine in the morning is I go out of the house, I'll put my bag of stuff in the back of the car, turn on the APRS radio, hop in the front seat, start the car, and normally I can hear WOR. Then I plug my smartphone in. And as soon as that LCD screen kicks up, boom, WR goes away. I turn on the GPS. Forget it. Totally gone. And I found where I used to be able to hear the station, I don't know, as little as 5 years ago, I have to go a little bit farther before I can hear it. And the noise floor recently, from all the storms and the unsettled atmosphere, there have been a couple of mornings when I have... Well, let's see. I've had to get to almost Paramus, New Jersey to hear the WR signal, and that's a good 30 miles from here. So, I had to be within 20 miles of the transmitter site in the null to hear the signal. Yet if I go out with a field intensity meter, everything's right where it belongs. So, the noise floor.
I'm kind of flying as far as watching the video of this podcast. Yes, we produce it. I'm flying a little bit blind here because I'm getting such a delayed signal. But I just sent to Burke a couple of spectrograph links from that article where Steve Johnson had done these tests. And if Burke can throw those up and compare the left-hand spectrograph and the right-hand spectrograph, never mind the picture of the house that's in there, that's the house that Steve went in and out of. This shows where the spectrograph is filled in between the carriers. That is the noise floor that we're talking about. The right-hand spectrograph shows a fairly normal relationship of carriers to ambient RF noise in the atmosphere, although I still think they're filled in quite a bit on the right-hand display. But he goes inside the house, and all this noise floor really comes up. The grass grows, as you might say, because it does look a bit like grass. And this is the kind of noise that we're talking about, or certainly one manifestation of the kind of noise that we're talking about. So anyway, that's I would point you to that Radio World article again if you want to have a look at that. We'll put a link to that in the show notes on thisweekinradiotech.com. But as Chris Tobin mentioned, it's from the June 16th, 2011 issue of Radio World magazine online at rwonline.com. And I think this is a very interesting study. It's, of course, the question, AM, as we've mentioned, gets affected by this kind of noise first because of the way AM receivers work. Tom, maybe you could detail that a bit for us. It used to be that when you wanted to listen out for a thunderstorm and you had no other way to know it was coming, one way was to tune your AM radio to an unused spot on the dial. I think on the lower end of the dial was typically better. And just listen to the noise, and when you'd hear the crash of lightning come through on the radio, you'd know there was a thunderstorm nearby or approaching. Tom, what can you inform us about, why AM has been subject to more noise, and then we'll move into why it's moving into other services?
Well, it's simply the physics of the way the signal works, Kirk. If you're talking an FM signal, the discriminator in the radio is looking for a frequency swing either side of carrier, and noise pulses tend to be amplitude related. So an AM radio obviously is looking for the amplitude change, and it's also looking for the extra sidebands generated. But if there are no sidebands there, and lightning comes up, or you get a noise crash of some type, whether it's generated by a microprocessor or what have you, the radio is going to hear it. Where the FM will tend to ignore it because it's looking for a frequency change.
Just because the FM just because the FM will ignore this amplitude crud, like in the case of a lightning stroke, a crash of energy, or in the case of just more typical broadband noise, you just hear more stuff between the stations. AM hears that. FM doesn't, you say, because FM uses a discriminator, looking for a change in a carrier frequency rather than just some amplitude. But I guess at some point we reach the point where the discriminator is being fed so much noise that I'm having a hard time putting this into words, but the discriminator quits working quietly because there's so much noise as it's trying to discriminate that carrier frequency change.
Well, the FM radio also has a limiter stage in it, and what that wants to do is it sets a threshold level for the carrier, so anything above that gets clipped off. Well, if you have a lot of noise coming in, you're going to have a lot of clipping going on, and you're going to generate noise inside the radio. And Chris Tarr was right before when he mentioned the HD radio and such. But if you looked at those spectrographs before, you notice that the noise rode up. Well, the HD radio signal's a little teeny tiny thing. It's, between 1% and 10% of the analog signal. And if it's down here and the analog's up there, but the noise floor is up here, up in this range someplace, you're going to bury that little HD radio signal. You're not going to be able to hear it.
Yeah, absolutely. Yeah, the desired to undesired carrier change is what's going to kill you. And looking at that spectrum, you can see exactly what Tom's pointing out, that as the noise increases, the spectrum where on the right-hand side you'll see the finger stock, if you will, the ups and downs, we'll assume those are FM carriers that they were monitoring. And in between the dark areas where the noise floor is and riding with the signal, right there is where the HD carriers are. And then to the left image, where you have just what looks like a black, zigzag hashy line and one or two strong carriers, the HD is gone. At that point, I can't imagine the bit error correction in the HD receiver would even function well enough to get what you want. That's what I think is what we have to watch out for. Even though FMs eliminate AM through the limiter stage, there is still the principle of RF capture and RF overload. So an RF overload could be anything. It doesn't have to be intelligible noise. It could be unintelligent, if you will, or random noise, and that's enough to swamp a receiver. And I think that's what this gentleman, Steve Johnson, was trying to point out. Was saying that we need to be looking at broadband noise more toward how it impacts everything for FM 88 to 108 megahertz, and the graphs tell it right there. And any of us who've worked in the digital domain in RF and AM and FM and even TV, I've worked with the TV guys with HD TV, and the first thing they talk about is noise floor and spectral regrowth as the growing grass, as Kirk pointed out, and that's where you get burned. Because you're dealing with carriers that are spectrally wide. It's not just a single carrier up and down. It's across time and frequency.
And the other issue we have to run into here is it's not just broadcast, AM, FM, TV. It's all across the services. And what's happening as a consequence of that is a lot of these other secondary services, what do? They increase the efficiency, turn up the power a little bit, change your antennas around, and just add more to the noise floor. It's essentially, okay, I can't hear you, so I'm going to yell louder. And that just contributes to the whole problem. So it's kind of this spiral, as you will, that gets started, and it just keeps getting louder and louder and louder, and there's really no solution in sight at this point.
This reminds me so much of back when they were called class 4 AM stations that were 250 watts at night. 1,000 watts during the day. They all got to turn their power up, or most of them did anyway, to 1,000 watts day and night. I was working at WEKY in Richmond, Kentucky, when that word came through from the FCC. We were allowed to be 1,000 watts day and night. And even at 1,000 watts, coming out at 1340 AM, you could see the tower and not pick the station up. You could be like 7, 8, 9, 10 miles away from the tower, see it on a hill on the south side of Richmond, Kentucky, and all you hear on your radio is just a bunch of noise. Hey, I'm looking at Steve Johnson's article here, and he says here, points out kind of what I thought he would. He points out that on the spectrographs, his spectrum analyzer was configured to show conditions across the whole band, I guess he means the FM band, as Chris Tobin thought, in a very broad manner. The settings would not be appropriate to measure an individual signal. He goes on to say, the strongest noise sources I found inside the home were recently manufactured wall wart switch mode power supplies used for charging batteries and cell phones and digital cameras. Some made a broad hash, while others produced a series of noise peaks on discrete frequencies through the band. That's kind of what happens when you got a lot of square wave, probably related to the switching frequency. He also said that some HD TV sets and DVD players were also very noisy in the FM band, maybe from their power supplies as well, but with their internal supplies, it's impossible to be certain for sure. Some personal computers and digital clocks and telephones were also quite noisy in the FM band as well. He says the urban apartments that I checked were also awash with noise, much higher than the background level in the parking lot outside. With fewer square feet of space, noise sources are concentrated more so than a single-family home. You know, I guess this is all very predictable, and I'd kind of like to look at talking about, okay, what's going to happen from here? As Chris Tarr said, you know, we all just yell louder. Back when allowed Class 4 AMs to turn up to 1,000 watts at night, well, you still could, after they all did that, you still couldn't hear them so well. That ostensibly was to overcome some man-made noise, but this was back in the mid-'80s when we were cranking up AM stations to overcome some man-made noise. And again, you know, here again, we're talking about this in terms of broadcast reception, but this has got to impact other things as well. You know, a switch mode supply that's throwing out noise doesn't care if it's throwing out noise in the AM band, the FM band, the police radio band, the aircraft frequency band, or bands that you may be using with your cell phone to communicate, to get, you know, the latest 4G services. It's not a respecter of those things. Tends to be that the, you know, lower frequencies get noised up first, because a lot of these, like switch mode power supply circuits, work at a fundamental of, I don't know, maybe 30, 40, 80 kilohertz, something like that, and then you have harmonics that go well on up into the AM band and perhaps higher than that. I was thinking about, okay, what if they mandated these consumer products to be less noisy? Well, then you're going to pay more. They're going to have more shielding inside of them, more multi-layer circuit boards that have, ground planes on the top and bottom layers. I just bought a widescreen TV. I think it was on Woot.com for $370. And, you know, what if that, you know, a product like that was subject to much more stringent RFI requirements? What's it going to cost then? I don't know. If you guys give some opinion on this. Mr. Tarr, what do you think about regulating things more heavily? What's going to happen if they do that?
Well, you know, I'm not a big fan of solving things by regulation. And in fact, we were just talking in the chat room here about different types of wall warts and things. I think there are smart ways to regulate this, and there are the hammer ways. And I think some of the green initiatives or some of these power supplies and equipment will help. You know, they have the new switching supplies that are a little bit smarter that go kind of into a hibernate or a sleep mode where there's no load attached to them. People are now buying power strips that shut down everything when you're not using them. So, you know, there are some other solutions to that problem other than mandating things. I think, I just think that as time goes on and this problem gets worse and worse, I think there are some other things at work that at least kind of help out a little bit in terms of the way that manufacturing is being done on some of these power supplies and some of these electrical things. But, you know, I would like to think that regulation is the answer, but in this case, I just don't think it is. I think you're right. It's just going to make things more expensive, and I don't think that. I think the genie's out of the bottle at this point. You know, so we need to talk about ways to do it in a better, in a smarter manner with shielding and green technology, as opposed to just saying, hey, you have to make these things silent. Because I just don't think it's going to happen, especially with all the devices being made and imported and exported. And it would be way too difficult to do.
You know, Chris, I like what you're saying, but I'll remind everyone, you live in the area that doesn't have this problem. So, Chris Tobin, okay, New York City, where they regulate the water flow from your showers. What is there an answer to this problem in an urban area?
The answer to the problem, well, unfortunately, I don't think we're going to find an easy one, because if you remember, the FCC, I'm just looking now, has licensed a lot of stuff in what they call the ISM bands, the industrial, scientific, and medical bands, and they're all the allocated unlicensed RF emitters that are allowed to use, and the regulation and monitoring of that is so minimal that that's where a lot of the problems will come from. Just people using I should say, permitted emitters. So it's unlicensed, so there's no regulation. I'm not a fan of regulation either, but there is a certain need of a certain decorum as to how you handle stuff. But it's gotten too far away. I don't know if we can actually rein it in, if you will. The toothpaste is out of the tube, the genie's out of the bottle, and now it's a question of how do we try and preserve what we have and understand better how to work around it. And I think that's something that we're not doing enough of. And there is no easy answer. I mean, think about it. All the unlicensed Wi-Fi that's out there, 5.8, 2.4, all that stuff generates all kinds of energy. And if you're in the right proximity, your cell phone will have problems, let alone your Wi-Fi. And then AM is just unfortunately going to be screwed because of the nature of the noise itself. FM is just now starting to feel the effects that AM has had to live with for the last 20, 25 years. When you really think about it,
it would be. I was just looking at this. I'm sorry. Tom, you go ahead. Go ahead.
Yeah, no, I was going to say, you mentioned CFL's compact fluorescent lights before, and someone in the chat room mentioned them and mentioned the new LED lamps. At Field Day this year, which was a couple of weeks ago, our ham radio club picked up a bunch of these little LED desk lamps. It's funny, we didn't hear any extra noise from those. And Chris Tobin may have been at this SBE meeting we had. It was, about a year, maybe 2 years ago. Living in the New York area, we have a lot of advantages for SBE and for manufacturers. Matter of fact, we have Middle Atlantic products over in New Jersey, and you may know them as the guys who make racks. Well, they do a lot of other things, and one of the things they were working on was a new type of conduit for wiring in homes, or not homes, but homes, but businesses, primarily businesses, that would allow you to be a little looser with how you handled the wires and the twist among them, and to keep the magnetic field and electrical field inside that conduit. And one of the things Bob Schluter, who is the owner of Mid-Atlantic, did, he pulled out a compact fluorescent bulb and showed us the waveform. And let me tell you, the waveform going into this thing is horrendous. It's a absolutely fierce triangle wave. Then he brought out a dimmable compact fluorescent bulb, and the current waveform going into that was almost a pure sine wave, just like the voltage was, and it was a heck of a lot quieter. And to make it dimmable, they have to do it that way. And I'm not quite sure exactly what's involved with the ballast, but the ballast is so different that a dimmable compact fluorescent bulb will be a heck of a lot quieter than a regular one.
That was a great meeting.
They mentioned this, the thing about they thought LEDs were perhaps more noisy. An LED running off DC shouldn't make any noise at all, nothing appreciable. I would think that the noisy part of an LED lamp is going to be the power supply that's running the LED. That may be where the problem comes. The LED's current draw typically is a power draw is pretty low. I'm just wondering if it's kind of difficult to make a switch mode supply that not difficult but expensive to make one that's quiet. And I think it's all a big matter of cost here. I was just looking at, while you guys were chatting, I was looking at this little power supply. This is from Blackberries, who made this little supply, and there's a UL listing. Of course, that doesn't mean it's quiet. I don't think that means it's not going to catch on fire. And it's safe to hold and such. I know that at the company I work at, my employer, Telos Omnia Axia, we sell all kinds of equipment in Europe, and so we have to get CE certification on them. And so they all have to go to a testing lab where they have this, I guess, an anechoic chamber, and they measure our equipment with cables attached to see what it does, and I guess with cables detached, and to determine what kind of cable you might need. And it's expensive to do, but I tell you what, it can be difficult to design circuitry such that it meets all those CE specs. This little BlackBerry supply doesn't have a CE certification on it, so I wonder if BlackBerry makes different power supplies for use in Europe where they need a CE sticker on them. Anybody have any notions about that? I got a feeling this is noisy, and maybe ones that go to Europe are not so, unless there's different classes of ones like like for consumer goods versus stuff that Telos, Omnia, Axia makes?
Generally I don't see that, just because it's to manufacture them differently actually costs more than manufacturing them the same to the higher standard. So a lot of the stuff I see tends to be classified for all that, and they just label them differently. But you triggered something that I recall here when you're talking about the switch mode power supplies with LED lights. We have an issue here in Wisconsin that's starting to crop up. Our Department of Transportation and all state highways have moved to LED stoplights. And aside from the fact that one of the problems we found out was in the winter, the snow doesn't melt off the front of them. So people can't see if it's red or green or anything else. The other problem is have your AM radio on and park at an intersection with one of these. You can't hear anything. The noise is so bad from that all of these LED stoplights are generating. So, even things like that have an effect. And I'm imagining that's not just going to be an issue on AM frequencies at these stoplights, at these supplies. But, you've got an intersection with, in the tens of these lights with matching power supplies for each lens. It's noisy as heck at an intersection when you've got those lights around.
Interesting. Chris or Tom, any thoughts about certification and whether I know that as a manufacturer, when I worked at Scott Studios, we had to set things off for certification, or we had to supply cables that had toroidal ferrite beads on them to keep too much emission from happening. I know that even on something as seemingly simple and direct as an AES EBU digital input or output connection, that's got to be designed right. Otherwise, when you connect a cable to it, there's going to be too much junk being emitted out to the air through the cable that's carrying the AES EBU. You guys have thoughts on this? Broadcast equipment maybe versus consumer gear?
Well, I think that broadcast equipment is held to a higher standard than some of the consumer stuff. Also, with the certifications, whether it's CE, UL, NSA, and all the others that are out there, or US, UA, or something, I forget the other ones. A lot of it is just basically if you intend to sell that product in a particular region, then you need to be certified. So, in the case of your BlackBerry power supply, that wall wart, as we're affectionately known as, it's very possible they have two forms of, two products they ship. And for domestic United States, North America, they ship those out. And then once they're in the field, that's it. If you take it with you on travel, it's not regulated. So you can take that overseas, put an adapter on it, because it's most likely a 47 volt to a 200 to 220 volt switching supply, and then you just put an adapter on it, they're done. They've met their obligation as far as in the United States. If you travel with it, that's your own thing. In a commercial environment, from what I know from talking to folks who do manufacturing, a lot of broadcast stuff is just a higher standard, believe it or not. Consumer can get away with a lot more, and it's just because it's used in residential, and I guess different environment. That's how they look at it. So yeah, it's a tough one. It's a tough balance, and as Chris pointed out, it does come down to cost, benefit and cost. At one point, do you as a manufacturer, take the hit on your margins?
So I know that there was a time when we at Telos Omnia actually were designing some RF shielding to keep RF interference, EMI, from getting in or from getting out of a circuitry, and we were up to like an 8 or 10 layer circuit board with the top and bottom layers being big ground planes. And then we were also looking at the fit of just the metal case to see if we could we were actually examining things like the Xbox and other maybe a Nintendo box, and we were looking at how they achieve some RF shielding just through using carbon in the plastic, and how the fit of the edges of the box go together to try to create an RF seal. Now, somebody in the chat room pointed out, hey, you drop one of the, you drop a product that may meet spec, especially a plastic consumer product. You drop one of these, or it gets repaired for the first time, and all bets are out the window as far as it's meeting any certification, if it did meet, in the first place. Hey, guys, we're going to pause it right here, and I'm going to tell you about our sponsor, which on this episode is my employer, and I appreciate them sponsoring the show, and that's Omnia Audio. The website is omniaaudio.com. Omnia spelled O-M-N-I-A. OmniaAudio.com. At Omnia, there's a couple of new processors out, audio processors for FM and for HD, and I'm going to give you a little bit of a detail about them. The first one I want to tell you about is the Omnia 11. The Omnia 11 is shipping now, and in fact, I just heard from Frank Foti that the version 1 release software is now shipping. So no more beta software. It's release software, and it looks really good. Not only it looks good, it sounds fabulous. And sure, anybody can say it sounds fabulous. But let me tell you what my experiences actually have been. The first time that we demoed an Omnia 11 to anyone was a major city, East Coast, and the engineer was actually one of the engineers who had a hand in developing the Omnia FM hot algorithms. And he said about the Omnia 11 on his station, he said, "Wow, it sounds effortlessly loud." Now, isn't that a change from what audio processors usually sound like when they sound loud? You know, in audio processing, to sound loud, it seems like you got to pull out every trick in the book. You got to do a bunch of high release time, fast release time HEC. You got to do a lot of multiband limiting and really be aggressive about it. And then you got to get into the clippers, and clip that audio really hard just to the point where it's not too irritating. And you put that all on the air, and it may sound loud, but it sure doesn't sound effortless. In fact, most audio processors, when they try to get loud, they kind of sound like this. They really try to sound like they're being loud. Well, the Omnia 11 is different. It really is different. And the reason it's different, or what makes it different, is that the Omnia design team, Rob Guy, Corny Gould, Frank Foti, and others, have worked tirelessly on developing algorithms that result in low intermodulation distortion. And IMD is what plagues all audio processors. IMD, intermodulation distortion, is what happens when two signals, like an audio signal and a control signal, or maybe a mid-frequency audio signal and a low-frequency audio signal, it's what you get when these two signals combine in a non-linear circuit. And what is a compressor? What is a limiter? What is a clipper? They're all non-linear. You don't get out of them exactly what you put in. You get a gain-changing environment, and depending on the speed of that gain change, you're going to get different forms of intermodulation distortion. And frankly, as an engineer, I've heard intermod distortion for years. On competing audio processors and on Omnia audio processors. And what's different about the 11 is Frank, Corny, and Rob have just taken incredible measures to develop new ways to get rid of IMD, to mitigate it, to minimize it, and in some cases, even to hide it. That's right, hide the IMD under other audio so that your ear doesn't hear it. And that's one of the many techniques that they've used to get IMD down to the point where it's not perceptible. What's the result on the air? Well, the result on the air is you get audio that is as loud as any other station on the dial. You stand up loud and proud, but it's so clean. It's so absolutely listenable. You hear things in the audio that you never heard before. I think on an earlier episode, I may have told you that one late night, I flew into Cleveland, Ohio, the headquarters of Telos Omnia Axia, and I got a rental car. And I was kind of pleased with the radio in this rental car. It sounded really good. I'm driving and I'm listening to the very end of a show, and then they played the top of the hour ID. It was a rock station, and they went right into a Fleetwood Mac song. And I thought, oh, well, that sounds like a refreshed mix of that Fleetwood Mac song. And so, in fact, I'll bet there's an Omnia on this station. I'll ask Corny about it in the morning. So I, came into Omnia that morning. The next morning, I said, Corny, I was listening to W blah blah blah, and sounded really good. What's playing there? Did you go there and tweak their Omnia 6? He said, no, that's an Omnia 11. So, oh, that makes sense. That's why it sounds good. That's why it sounds like I heard a new mix of the Fleetwood Mac song. You hear detail that you've never heard before. A lot of presets in it, but I tell you what, the first couple of presets you try, you're going to find one that you like. The Omnia 11 can do just all manner of processing for your analog FM and your HD. Check it out. There's a brochure on the website. There's some pictures on the brochure that help you understand a lot about the signal path, and there's some white papers by Frank Foti on there that explain a bit more about the Omnia 11. I'd like you to check it out. I did mention at the beginning of this announcement the Omnia 9 is also being a new processor. That processor was shown at the NAB show. It's coming out this fall. It's the one designed by Leif Clayson. We have a great collaboration with Leif. And the difference between them, well, here it is in a nutshell. The Omnia 9 has a feature list as long as your arm. It does all kinds of things. It does the dishes. It makes mounds of julienne fries. The Omnia 11 is a bit more of a one-trick pony. But let me put it this way. Oh, what a trick it is. Check it out on the website. It's omniaaudio.com, and you can check out the Omnia 11 or the Omnia 9. And thank you, Omnia, for being a sponsor of This Week in Radio Tech. All right, guys, forward, upward, onward with the show. Are we done talking about all this noise? Where are we going with it? How can we mitigate it? I guess we really don't have solutions. Are we just going to have to transmit stronger signals to overcome things that aren't regulated?
And the short answer, probably. That's what their HD carrier proposals are trying to do. Inadvertently, I think that's what the result is because of the noise floor. Also, on the topic of noise, for those of you watching and listening, if you really want to get a good understanding of grounds and electrical distribution for your facilities, both at home or at the office or in the studios, as Tom Ray pointed out, our SBE 15 chapter here in New York City did visit Middle Atlantic Products in New Jersey, and it was a great session. And they have a white paper. It's at the website. Just go to the middleatlantic.com and look under white papers, sessions, I think, and look for the one regarding power in the home or studio. And then all I'm going to say is if you're really curious, look up bootleg grounds, okay? A bootleg ground. We probably all have them in our studios. Yes, okay. Bootlegs. Okay, but it's a great paper. You sit there, read it, you say to yourself, wow, things that you and I probably have been doing for years and thought was correct actually contribute to some of the problems we experience.
Interesting.
Yeah, it's a great paper.
I'm seeing the links to it right now. Yeah, middleatlantic.com. In fact, you can go right to it, middleatlantic.com/power.htm. We'll put that link on the thisweekinradiotech.com website as well. You know, some manufacturers really have put a lot of work into white papers. I really like some of the papers that Orban has put out at the end of their manuals. They have a paper on getting clean audio. Frank Foti at Omnia, of course, sponsored the show. Has a number of white papers. Nautel has a terrific paper that's at the back of many of their manuals, or maybe it's a separate manual about surge protection and keeping lightning out of your equipment. And so Middle Atlantic does. What's the word for it? They do computing centers. What's the word I'm looking for? They do racks for
data
server
centers.
rooms and data set. There you go, data centers. And so they got to know about proper grounding. I guess in the consumer environment, grounding. You have no control over that in a consumer environment, and most of this noise we're talking about is coming from the consumer environment. Do we have any idea how much of this radio and background noise is coming from things like power distribution? I've heard that figures like upwards, and this may be just totally wrong, but I thought I heard upwards of 50% of the power generated is lost through inefficiencies and noise generation through bad insulators. And the power companies sometimes won't replace a bad insulator until it gets to the point where it's either dangerous or just genuinely arcing over. Making a little bit of noise? Don't worry about it. You guys know about this?
But if you can spot something and prove that it's making noise, they are under obligation from not only the FCC, but their state charters to eliminate that noise immediately. And there are cases, and I've read these in ham radio magazines, where the FCC has actually fined the power companies and told them, you correct it by this date, or the fine will start escalating. So if you can identify where it's making noise, they have to come out and fix it.
Chris, Tarr, in your part of the world where it's kind of rural, do you have power company noise? Is that a problem for you?
Oh, sure. Well, especially out here, because most of our power is overhead lines, and they stretch pretty far out. Now, where I'm at, I'm in a new subdivision, kind of near the village center. So, all of our lines are fairly new and well cared for. But, there are, infrastructure does age, and especially in areas where, there's a lot of space between houses, and there's a lot of that out here. You do have real long runs of cable, and the infrastructure is fairly old. So we do have some of that, and Tom's right. If you do find noise and you can attribute it to something going on with the power company, they're required to fix it. However, I find that a lot of these issues are really just inside the house. Things just like, you have all these, cordless phones, cell phones, switching power supplies, LCD monitors, computers, all generating to the total, noise temperature in the house. It's, nothing compared, the stuff going on outside is nothing compared to what's going on in your house. But even, some things we have here, believe it or not, that cause interference are things like, fences that are keeping the cows in. A lot of times they get, they get rusty or they corrode and they start to, make very good incidental radiators. So, we have issues like that out here as well.
Well,
I was going to say,
Hey,
they also make.
Taking a call there, I see.
yeah. Well, the daughter was at the mall and she's calling. So anyway, I said, hey, hang on a few more minutes. We're going to be done with the show in about 10 more minutes. I was just thinking about this. Will this problem of noise solve itself? And I don't see it solving itself for a couple of reasons. And one is consumers want inexpensive gear. They want to, here's a battery charger that's $4. Here's a battery charger that's $29. Of course, usually the $4 quality one is $29. But I don't see people wanting to pay more for a benefit that they can't see. Now, the other part of the problem is, indeed, you can't. All is that a radio station you used to be able to pick up, you can't pick up anymore. But you don't know why. The average consumer would have no idea why, and even for an engineer, it might be hard to track down. If somebody would develop some RF visualization glasses, right, and you could put these specs on and look around your house and see all the sources of EMI, do you think consumers would say something then to manufacturers? Hey, I'm not going to buy your power supply anymore. Look at that TV. There's all kinds of stuff coming out the back of it. Wouldn't that be interesting? See, there's this big gap between the consumer buying a product and plugging it in and relating that to some interference that they experience either then or later on. Isn't that a big problem? If they had some instant feedback, couldn't that change things?
Actually, I think most consumers would probably run screaming from the room because they really wouldn't comprehend what they're looking at and they think they're going to die.
Yeah, I don't see them. I don't see them caring much, even if they could see it. I just think that, engineers are wired a little differently. We know what's going on and can separate that. A consumer, I'm just imagining my mom caring about that. It's like, okay, so what does that mean? So I do think it's an uphill battle. On the other hand, I think the fact that we're kind of dealing with mutually assured destruction here can be a good thing. It could be that at some point it gets so bad that, at least the big players get together and go, you know what, we need to do something because nobody's winning at this point. And we need to put pressure on, because, for example, the power supply you're talking about goes for a cell phone. Well, what happens when the cell phones start, not working real well or becoming very inefficient because of the noise? They may trace it back to, okay, we need to make our, we can do our part by making our power supplies a little less lousy. So, there may be some of that. Maybe I'm an eternal optimist and am completely off on this. But I'm hoping that the whole kind of mutually assured destruction part of this kind of causes everybody to reassess it.
That's plausible. I would agree with that. That's a good way to look at it, because I don't think there's a solution in sight, and there won't be. It's really cost benefit. And I just looked at my BlackBerry power supply, and it does have a CE certification and all the other ones. So I guess mine's a newer version than yours, Kirk.
Or maybe it's a real BlackBerry one, and mine's a cheap knockoff.
Yeah,
so you're the offending signals that are interfering.
Yes. All that hash is coming from my hotel room in Miami right now. Oh, gee. Well, I don't know. I'm depressed about this now because I just see this as being insidious, and consumers getting fed up with their electronic gear that doesn't work, that doesn't receive well, their Wi-Fi that keeps quitting, their 4G reception that is no good because of noise. They can't hear AM at all. They haven't tried in years because the last time they tried it didn't work very well. And then FM starts getting worse. I don't know. Am I just?
Well, on the other hand, Kirk, we're our own worst enemy because those Wi-Fi signals and those cell phone signals and those Bluetooth signals and that all adds up too. I mean, you're talking about things that are unintended radiators, but we have a ton of intended radiators too that add to this problem. So it's not just the switching power supplies that are causing the problem. It's these devices in aggregate, and even the cheaply done Wi-Fi and cell phone or not cell phone in particular, but cordless phones, are all over the place in terms of frequency and splatter and stuff. So, even if you were tomorrow to fix all the unintentional sources of noise, I still think we're so far ahead with wireless being the big thing now, wireless everything, that it's going to be real hard to overcome that ever.
That's our show title, Devices in Aggregate. There you go. That's kind of described it. Hey, what happens when we have, there's people who are working on wireless power distribution technology. Now, people who are afraid of RF radiation now, coming from their little wimpy cell phone, they ought to be really afraid of the kind of fields that you'd need to have wireless power transmission, shouldn't they? Or am I misunderstanding what some people are proposing?
There may be
Nobody
some
knows.
concern there. It is, it's wireless, it's radiating, it's inductive. I mean, near-field communication devices are now coming on the market. There's another noise generator possibly. It's even more in close proximity to any radio receiver you might want to use at the home or at the office. Laptops are now going to have them, and I think iPhones and smartphones are coming out with them. So yeah, we got a lot of noise on the front coming.
A few years ago, I was joking with a friend of mine about, so we're going to start making wireless power cords. They're going to come in 1 meter and 2 meter and 10 meter lengths. You pick your length and your wireless power cord. And yeah, but imagine if people. I mean, people want wireless. That's true. I've got a desk full of wires here at the hotel for all these things. What if it was all wireless? Well, that would be kind of cool. But that RF has got to be, somewhere, and the generation of that RF, invariably, you generate RF in other areas that you didn't intend to, and even the receivers, they all have local oscillators, so they're generating a small amount of RF in order to pick up the RF that they want to pick up. I mean, why do you think that they ban, cell phones and other devices on aircraft? Because the weak signal, the weak AM signal that the aircraft, is trying to receive. Okay, I'm not talking about GPS, but the VOR signals, really easily screwed with when you're 70 miles from the VOR and there's a good little RF radiator sitting in somebody's hand right inside the plane.
Oh, it has nothing to do with that. It's the airlines. They can't get money out of the phone carriers. That's why.
Yeah. Well,
kidding.
there's some truth both ways.
No, you're absolutely right, though. Yeah, it's uncontrolled radiators in a confinement like that. Yeah, you still run the risk of trouble, and that's life safety at that point.
Yeah. I don't know. Tom, I've been pretty pessimistic here. Tom Ray, you got any optimism for me?
No, not at all.
Well, at least you're honest.
No, what I've noticed, like with LED traffic lights, and actually anything that comes out that's new, at first it'll be noisy. The next iterations of them that come out tend to be a little quieter because the companies, the first time they put the thing out there, they're rushing it to market, they're trying to get it out. And then it kind of starts quieting down a little bit because they refine the design a bit and make it work better. So, I don't know, they're while we still may be getting noisy and probably getting noisier, there might be some hope. I don't know where, but there might be.
Are there modes of communication that are really resistant to noise? And as ham radio operators, you guys ought to be expert in some of this. Tom, do you ever do any of these digital modes that just need the very tiniest of intelligibility over noise ratio?
Oh, I'm on PSK 31 all the time, and I'm surprised at some of the signal levels. I mean, I can barely see anything on the waterfall display, yet here comes the text, and we have a nice conversation. So, the digital modes tend to be a little more robust than some of the analog modes, but of course, the analog modes, even when it gets noisy, you can probably still pick something out. With the digital modes, there's that cliff effect, and it goes away. And of course, there's always the ultimate digital mode, Morse code, and that stands up under a lot of noise.
somebody in the chat room, in fact, it's college engineer, mentions radars. He says boat radars. Living in Nashville, Tennessee, I don't come across many boat radars, but that's just another source of noise to contend with. Hey, for broadcast engineers who are anywhere near a naval base, I know a lot of them have had trouble using a satellite receiver to pick up the radio-oriented satellites where there's radar nearby and it interferes with the C-band reception. And you guys have had problems with that and been able to filter it out?
Oh, sure. Yeah, we have a satellite dish looking right across the Hudson at about 9 degrees above the horizon for AMC-8, and the cruise ships come in. We've had a fleet week during July 4th weekend, Memorial Day weekend. We have the fleet come in, and they sometimes forget to turn off the radar, wipes out everything, and sets off the car alarms in 5 different boroughs. But, yeah, we get that all the time. And there are products you can buy to filter out most of that C-band interference.
And at the WROR transmitter site, we line up with runway 22 left and 22 right over at Newark International, and not many people know this, but the altimeter on the airplanes, it's actually more like a sonar, and they run just above transponder 23 on the C-band, and boy, every now and then we get a plane that goes by and it's off frequency just a hair, and boom, we get wiped out for several seconds, but it's enough to really cause all kinds of grief.
I hadn't thought about that. Yeah, the radar altimeter that they have to give them a good, accurate reading above the ground. There's all kinds of sources. I'm sorry, go ahead.
I was going to say, now out here what we have is we've got cows crossing the parking lot, and they block the dish, and then it just goes out for minutes. Until we get them out. Hey.
Wait, now what do we call that? I mean, if somebody digs up your fiber, it's called backhoe fade. Now, what do we call that when a cow gets in front of the dish?
Bovine fade.
Bovine fade.
Oh, yes, the problems that engineers have to contend with will just never cease, will they? That's why the show will just go on forever. Hey, can you imagine the four of us doing this show in 30 years from now? What'll that be like?
But Chris, when the signal's blocked, at least you get free milk.
Or dinner. Yeah.
Or dinner.
Steak. That's what's for dinner.
Hey, guys, let's have some wrap-up comments here. If there's anything else you want to say on this subject, I think it's going to come up again. This whole subject of the noise floor around the world, or at least in populated areas, is just going up and up and up, and making the services that you want to listen to. Oh, yeah, earlier in the show, I just remembered to ask this now. What is this increasing noise floor going to do to these so-called white space devices that are supposed to be able to look out for the presence of presumably a broadcast signal? Finding none, they can use that frequency. Well, if there's all this noise going on, are they going to be able to use unused frequencies? Because they'll all be used by noise.
Well, it'll just be one less thing using the frequency
to increase the power on those things, and it'll just spiral down from there.
Mr. Tarr?
Yeah, I have Electrosonics digital tuners for the wireless mics that we use. It has a smart front end, and you can scan the block of frequencies that the receiver works within. And on a couple of events we've done outside broadcasts where the noise floor is just enough that it would lock on. It would not lock on. It would tell you, oh, there's signal here, not usable frequency, move on to the next. And I dial up the frequency manually and go, well, there's nothing here. I definitely can override that noise floor that's tickling the meter. So those white space detectors, I think, will get fooled on many occasions in urban areas. New York City, Boston, Chicago, probably, but other areas they should do just fine.
Okay, all right, Mr. Tarr. Sorry, everybody talks at once.
Oh, I was just going to say, that might be one of the benefits, actually, because
Shut up.
If the microphones don't turn on, then we're not going to have anything adding to the white noise.
Well, that's true. Problem solved, or at least mitigated.
Yeah, exactly. So I think it's a win-win, really.
Yeah, it's a win-win. Jesus. All right, guys, we're going to call it a close here. We've been going for an hour. I want to thank my three co-hosts for being with us on this episode where, once again, we've talked about a subject that we're only mildly familiar with, but we sure give it our best college try and, hopefully provide entertainment for you and a little bit of information as well. We think about a lot of possibilities and what would happen, what ifs, and things like that. Thanks for all the comments from the chat room, too. I appreciate that very, very much. Chris Tarr from Muckwonago, Wisconsin, thanks for being with us.
Thanks for having me.
We enjoy it very much. And Chris Tobin, the best-dressed engineer in radio from Manhattan.
My pleasure as always, and thanks, Kirk. I got to make sure I do this.
Yes, thank you, Burke. And from the Hudson Valley of New York, Tom Ray and WOR. Thanks, Tom.
Hey, it's been fun making noise about noise. And by the way, thanks, Burke.
That's good. All right, Tom, thanks for your pithy comments. We'll see you next week when on the show. You can always catch the show at thisweekinradiotech.com. You can also go to the Twit site, twit.tv/twort, where you can pick all manner of ways to subscribe to the automatic downloading of our show. And we sure thank you for your comments and your emails and listening to the show. Tell your friends and tell your engineering friends about the show. They might be interested. They might not like you anymore for recommending it, but we'd appreciate it to get the word out. We will see you next week right here for This Week in Radio Tech. Bye-bye.